ultra low sulfur diesel will hold 0.1% of its volume of water. What that means is that if you have fuel, this happens to be a sample of local diesel fuel, this fuel will hold 0.1% water dissolved in it. That means you can't see it, it won't be cloudy, any of that. It's just in the fuel. The thing about it is, that doesn't sound like much, but think of it this way. That's 1 gallon in 1,000 gallons of fuel. So if you break that down, that's a quart in 250. So in a lot of over-the-road trucks, they have 250 gallons. You can have a quart of water dissolved in your fuel. The hotter it is, the warmer it is outside temperature-wise, the more water the fuel will hold. The colder it is, the less it can hold. So let's just say you pump fuel out of the ground, and today let's say it's 55 degrees, and you put it in a bus. It sits over the weekend, and during the weekend it goes down to 20. The fuel can hold less water. When it can hold less, it pushes it out into liquid water. So it is very possible to have a bus on Friday with no water in the fuel tank, and on Monday come in and have one with water in the fuel tank that you can see, because it will push it out as it gets colder. So you can have those kind of problems just based on temperature. And the colder it gets, the worse it gets. And when it's warm, the higher the humidity and the higher the temperature, the more water the fuel will pick up. So ultra low sulfur holds 0.1%. Biodiesel holds 1%. It holds 10 times as much water. So you can have, if you think about it, you add 5% biodiesel to your fuel, it has more water in it. Now the whole thing can hold more water than it could. That's important. Biodiesel more readily grows bacteria and fungi. Any diesel fuel will grow it if it has water available, but with biodiesel you can grow more stuff. This here is just a picture. I wanted to show this because a lot of people have asked. This is cooking oil, used fryer oil basically. The next step is we try to get the glycerin out of it. So we filter it and then we get the glycerin out of it. And then we make biodiesel out of it. Interestingly, the processes that we use to make biodiesel out of cooking oil, called transesterification, uses water. So we're actually putting water into that fuel in the process. So you end up typically with fairly high water content. One of the other issues with biodiesel that has become, certain engines have more of a problem than others. There's a Mercedes engine and a couple of Cummins engines that have a big problem with it. When you run an engine, any engine, gas or diesel, a small amount of fuel gets by the rings and gets into the motor oil. The heat from the engine typically will vaporize the fuel, the diesel fuel, and then it gets pulled out by the crankcase ventilation system, which is like a PCV system for diesels. The thing about it is biodiesel doesn't vaporize as easily as regular diesel does. So the biodiesel tends to stay in the oil, and you will actually build up the amount of oil it looks like on your stick. It looks like you'll be a quart over and 2 quarts over. And we see them regularly where it's coming out the dipstick tube. And it's worse in engines that are used in your kind of service, where you have low load, short runs, long idle periods. All of those things make that worse. So if you see an engine that it appears to be building oil, the biodiesel thing is one thing to look at. And it can be quite a problem. This is just literally bottled water. Of all the fuel problems that we have today, water is arguably your biggest enemy. I don't know if you guys, I would assume everybody in here is, this is water finding paste. If you don't have this, you pretty much have to have it today. Those of you that are older than 40 will probably remember that people used to tell you it was all right to leave water in your fuel storage tank. They would say an inch of water is all right or 2 inches is all right. The truth of the matter is water has never been all right, but you could get away with it. Today, you just can't get away with it anymore. The amount of allowable water in a storage tank is 0. If you have an inch of water in the bottom of your storage tank, every time they dump fuel in it, that stirs all that mess up. It can be sediment, it can be water, and it doesn't settle out right away. It may take as long as a day for everything to settle back out. In the meantime, you're filling up buses with that stuff. On some storage tanks where they have a in-tank pump, just that in-tank pump is enough to stir it up and keep it mixed up. Water really is the enemy. So you put this stuff on the stick that you use to measure it, and it'll tell you how much water's in there. Seriously, if there's anything more than 1/8 of an inch in there, you need to get it out. There are different types of this paste, and I just brought this other one along today. If you have both diesel and gas vehicles, there is one type of paste that used to be for just gasoline. This is a modified version of that for gasoline with ethanol in it. And the reason that that's important is that ethanol attracts more water than diesel fuel or anything else. And if this stuff, if you put this on the stick and you start to see little yellow polka dots on the stuff, it means your fuel is getting to the point where you're going to have something called phase separation. And if you get a chance, go to your computer and look phase separation in gasoline, and it'll tell you why that's such a big deal. Anyway, back to this. This is just for telling if there is water in fuel. It doesn't really have any other use. I'm going to put a little on a Q-tip here. It's this lovely baby poop color. When it touches water, it turns red. That's its job. I'm not here today to talk about people's products. So I'm not here to say anybody's bad or good or anything. I want to just show you some chemistry differences. This is a very common chemistry that's used in diesel fuel additives. It's based on the chemical naphtha, which is something that they use to make gasoline. So that's in the first one. The second one here is a very simple chemistry. It's based on mineral oil. And it's literally the same thing as you would find in baby oil. This chemistry is different. This is called an organic surfactant. And it does a lot of things different from what the other ones do. And if you look at, just from me pouring it in, it looks different than the other ones. And anybody that wants to look at this is welcome to come up and look. So this one here, there's a very well-defined layer to it. If I agitate it, you get what we call an emulsion. It temporarily has mixed. One of the things about it is, if you look at that glass, you'll see there's a sticky, gooey, gummy substance on it that's related to that chemistry mixing with water. The thing about it is, in a few minutes, this will separate back out into water and additive. This one is literally oil and water. And if you've heard that oil and water don't mix, they really don't. You can agitate it pretty much as hard as you want, as long as you want, and in a matter of a few seconds, it separates right back out. It's just never going to mix. This chemistry here uses something really unique. It's called hydrogen polar bonding. I just want to see if you can see. There's like a reaction that's taking place in there right now. And when you're close enough, you can actually see that reaction. It completes very quickly. It completes in about 20 minutes, 30 minutes on its own. If you agitate it about this much, it finishes in about that many seconds. This is now a hydrocarbon. This is actually a burnable substance, and it is no longer water. It no longer will rust things. It no longer will cause the combustion issues. It will no longer cause the reaction with other chemicals. It's literally not water anymore. So I just told you this one here was the first one. You can see it's layered out already. I'm just going to agitate it for a quick second here because I want to show you something with it. We take a Q-tip again with our water finding paste, and we go along in here, and when I break up those bubbles, it still turns very red. It is still definitely got water in it. If you go along to the next one here, I'll try to do this. If you push it down into the oil, you just get oil. If you go down through the oil into the water, you've made no change to that water at all. This chemistry here, I can push it down in. I'll smear it along the sides like I did the other one. You can let it sit in there indefinitely, and there's no change to it. There is no longer any water present in there. It is a permanent chemical change, and it's the result of an actual chemical reaction. If you remember back to your high school chemistry, water was H2O. It's 2 atoms of hydrogen and 1 of oxygen. Diesel fuel, or gasoline for that matter, is a hydrocarbon. So it's primarily atoms of hydrogen and carbon. What our chemical does is it causes the hydrogen atoms of the water molecule to bond to the hydrogen atoms in the fuel. And so you actually get now, you've added the hydrogen atoms, which is energy, and you've added the oxygen atom, which is an oxygenate, to that fuel, and it's a permanent change. I've got a bottle of this that I did 9 years ago, and I've kept it for all these years, and it looks exactly the same today as it did 9 years ago. So the next thing I want to show you is about reactions with actual fuel. Not bad. Again, we have our water here. So water is heavier than the fuel, and it wants to settle to the bottom. A certain amount of it will get absorbed by the fuel, but when you have too much to get absorbed, it sinks to the bottom. When you take any hydrocarbon fuel, so this can be diesel, it can be gasoline, it can be biodiesel, you can do this In another version, you can even do it with natural gas, propane. It all reacts with water in some form of the same way. You very quickly get a gum that builds up. Let me show it here. It's a little better in the light. And you can readily see that gum builds up. Now, the longer I do this for, the more that gum will build up. And imagine that you then shut the engine off and let it sit. That dries out and hardens. Tomorrow you start it up and you start building a second layer on it. Diesel engines recirculate fuel, and they get that fuel hot while they're recirculating it. And this material, when it's heated up, first becomes a varnish. So if you ever looked at the fuel system, everything in a diesel fuel system is coated with varnish. When it gets to the next stage, it gets to the combustion chamber and it gets hotter, it becomes carbon deposits. So this very rapidly builds up carbon deposits. So, I'll show you here again. You can see there's some different reactions. There's water on the bottom of this one. There's water all the way through that column. This one here, the fuel and the baby oil are reacting. Water's at the bottom. This one here, there's water at the bottom, but there's stuff rising up and there's stuff falling down in there. And what that is that the product is actually reacting with the water. If you let this sit, it would take several hours, but it would clean up that water on its own. If you just agitate it for a few seconds though, you can get it to completely do it on its own. So now we have bound, chemically bound, all of the water that was in there to the fuel, and it is part of the hydrocarbon chain, and it will burn as fuel. And it is actually now what we would call an oxygenated fuel, so that will help it burn better. You can see on these two that the water is already starting to fall back to the bottom, whereas with that one there's nothing there. And you can also see it on the glass. The glass is very clean compared to the other two, which are leaving a deposit. I'm going to let those sit for a few minutes and then we'll come back to those. I just wanted to show you this, so I'll show you all three of these again. There's nothing here. These two have had that water go to the bottom in them. Because I need a little bit of what I call headspace here, I'm just going to pour a little of this in here. And a little of this one. The reason I want to show you this is that I told you today there's a lot of times you can't control what's in your fuel because you don't really know where it's coming from and you don't know who else has done what to it before you get it. So my point here is that even if somebody has done something to the fuel before, you can actually still make it better. you can still get rid of that water. You can still clean up the parts of it that make gum and varnish. Now on this next one here, this one has, as I say, baby oil in it. I can take care of the water. I can clean up the glass, but I can't change oil. So if you look at it, the glass is very clean. There's no more water that's going to fall to the bottom, but it's still oil. So it's not going to be as clean. But the point again is you can clean things up compared to what they were before. And I really think that's the most important thing. So this is a cotton ball material that you'd buy in the drugstore. And we've just rolled it up into little cotton balls here. And we just want to demonstrate something regarding diesel fuel. This is some local diesel fuel. This is from the Pilot just north of here. So diesel fuel on its own really doesn't burn that completely. If you use certain types of additives, you can actually make it worse. I just want to show you with this. You can actually improve the way it combusts. And interestingly, even if somebody has used another type of additive, you can actually improve the way that combusts also. So the big thing about the technology is that you're reducing the amount of soot produced. By reducing the amount of soot produced, you're reducing the amount of load that is put on the DPF, the amount of soot that's going into the EGR system and the cooler. So you're reducing all those things. You're reducing the number of regen cycles that are required, all of those things. It is possible to actually reduce it by up to 85%, the number of regen cycles and amount of soot load. The way that it's done is really very simple. Imagine just, if you would, a drop of diesel fuel this big. Diesel fuel, as any fuel, burns from the outside in. If you have a big drop, it takes a long time. If you take that same amount of fuel and you make it into 1,000 or 10,000 little droplets, those little droplets are much smaller. It takes less time for them to burn from the outside in. When you have fuel injected into the combustion chamber of an engine, you only have a few milliseconds for that fuel to burn. Anything that doesn't burn in those few milliseconds goes out as partially burned fuel or soot. If you make more smaller droplets, you increase the amount of fuel that actually gets burned. This product, as I said earlier, it's called an organic surfactant. A surfactant is a surface acting agent, and it reduces the surface tension of the fuel, and you make droplets that are roughly 8 times smaller than you do without it. So it improves the way that fuel burns.